Hello, everyone, and thank you for joining us for our webinar, Storing for the Season. We're happy to have you here with us today, and we have a lot of great information to share. So let's go ahead and get started. Our experts are here to help you properly store and care for your water quality instruments, whether it's between sampling trips or between seasons. So we'll be providing the best practices for both short-term and long-term storage to ensure that your equipment remains in top shape even when not in use in the field. So first up, let's meet those experts. Katie Marchand is our Environmental Applications Engineer, working closely and collaborating with R&D, marketing, and product management. She has years of field experience, which help her create helpful resources, training events, and webinars like this. Jessica Latsko also spent years in the field, working in watershed protection and drinking water, before joining us as a technical sales representative. Now she helps customers identify the perfect solutions for their monitoring programs. I'm Nate Christopher, Marketing Communications Manager, and I'll be your host for the webinar. And then I'm also joined by Kyle Just, our Marketing Specialist, who will help run our polls and moderate our chat. Our presentation over the next hour will cover major topics for short-term and long-term storage, as well as some essentials for instrument cleaning and care. But that's not all. Katie and Jessica will be on hand for the remainder of our time to answer your questions about how to get the best results from your YSI instruments. But now I'll hand things over to Katie to get us started.
All right, thanks, Nate. Hopefully you can hear me. Welcome, everyone. So let's set you guys up to get a long life out of your field instruments. That's what we want to do for you today. We're going to learn how to store them the right way. But before we get into all that, first we need to talk about some important things you need to do before storing your instruments. So when you're coming back from the field, your instruments are probably dirty. Maybe they're crusted with algae or sediment, or maybe you're monitoring wastewater or industrial runoff. So before any type of storage, it's a good idea to rinse the outside of your instrument, your handheld displays and cables with clean water. And we're just talking about the outside of your equipment here. We'll have specific cleaning and care instructions for each sensor coming up later. But if you need to remove stuck-on dirt or growth from your equipment, you can use a brush and mild detergent like Simple Green spray or a few drops of dish soap to help you get it off. And then if you have hard growth or something like barnacles, stubborn buildup, a white vinegar soak can really help dissolve and loosen it. You can use undiluted vinegar or 1-to-1 vinegar to water. And then if you have instruments with removable sensors, in general, it's a good idea to keep either port plugs or sensors installed in your instrument when you do any kind of vinegar soak. And cleaning is especially important also if you need to prevent cross-contamination between sites where you're using the same equipment. So clean your water quality instruments, but also anything else that touches the water, like weighting rods, measuring tapes, deployment tubes, etc. And for this, you can also use a germicidal spray if your SOP calls for it, but avoid the sensor tips definitely and rinse it off really well. And if you have an instrument with removable sensors, just so you know, we call the part where the sensors install into the instrument the bulkhead. And for an instrument that has military spec or milli-spec connectors on the bulkhead and what we call LEMO connectors on the cables, like any of the Pro Series or the Pro DSS, these connectors are not meant to get wet. And you also don't want to be removing sensors if you don't need to, because with these connectors, the repeated uninstalling and reinstalling of sensors can cause wear and tear over time. So only remove your sensors if you suspect you need to clean the ports, like if you're having issues calibrating or you notice something is off in your data. And of course, if you need to swap sensors. So to clean these ports, you're just going to flush them with isopropyl alcohol and then dry them with a small puff of compressed air. And make sure the ports are completely dry before reinstalling your sensors. You don't want any alcohol or water left in there. It can cause some damage. And also these ports, you do not want to put any grease in them. They do not like grease. And on the other hand, if you have an Exosun, there's a different process for an instrument with wet mate connectors. So wet mate means the ports can be wet and it won't damage the electronics. And that's because the connectors and the ports are coated in neoprene rubber, which is the black part that you can see in the photo. And that prevents water from getting into the internals of the actual electronics of the instrument and sensors. And also the EXOs have titanium bulkheads and sensors. So we aren't concerned here about wear and tear from uninstalling sensors, but we are concerned about properly cleaning and lubricating the wet mate connectors. So every 3 to 6 months or so, remove all the sensors, use a lint-free cloth like a Kim wipe to wipe out the ports, get all the dirt and old grease out of the threading. And if there's dirt stuck in the ports, you can flush them with DI water and dry them, but do not flush the wet mate ports with alcohol. That will dry out the wet mate rubber and be very bad for it. If a little moisture is left, that's fine. But make sure you re-grease the neoprene rubber on the connectors and the bulkhead ports. You're just going to use a small amount of silicone grease on your finger and rub it in there. Or use a flux brush to help you coat the black rubber. And we just need enough to make the surface shiny. So while you're cleaning your equipment, take the opportunity to inspect everything for damage, including the instrument itself, the sensors, and the O-rings. Look for cracks in the plastic or maybe tearing or old rotted rubber. And here's an important tip also as you're doing this, don't over tighten your sensors in the port. They just need to be snugged up by hand, and then use a sensor tool like you see in the picture, like the one I'm holding up here. You just do a short quarter turn to snug them up into the bulkhead. Over tightening can damage the O-rings. It'll possibly warp the connector or the sensor nut and make sensor removal very difficult. So let's talk about O-rings for a second. They are all over your instrument, at the connectors, on the sensors. So first, let's make sure to clean the mating surface, and that's the groove where the O-ring is sitting. If there's dirt in there, you won't get a full seal, and it will allow moisture to get in. So you can clean the threading and the O-ring gently with a soft bristle brush. And then to remove O-rings, always just use your fingers to pinch them up and grab them out. Rather than using a tool. If you're using a screwdriver or anything to leverage the O-ring out, it could damage the mating surface and damage the seal. So after you clean them, lubricate the O-ring with a little dab of silicone grease. Use your finger to rub it in, and that way you can feel for any nicks or cuts in the rubber. And if it's not smooth, go ahead and replace the O-ring, and then make sure to lubricate the new O-ring as well. Here's another thing to keep in mind. If you have a sensor that's stuck in your bulkhead, it's probably because the O-ring on the retaining nut has become snagged in the threading. That green arrow there is where you can see that little O-ring on the retaining nuts. So that little O-ring here is probably causing that issue. And you might just have to brute strength the sensor out of your instrument, as carefully as you can, and then clean it, and then remove that sensor and replace it with a new one. But if you're in the field and you have this issue and you don't have a backup O-ring, you can still use your instrument without it. That little O-ring is not helping keep the water seal, to keep it watertight in that seal. It's just there to help the retaining nut, but the retaining nut will still be able to hold the sensor in the bulkhead. Okay, now if you have wet mate connectors, like on your EXO, all the EXO sensors, cables, and accessories we have listed, I don't want you to forget about those. So we need to maintain the wet mate connectors regularly. Try not to leave your sensors installed for years at a time and never clean and lubricate them. If they're not regularly lubricated, it can cause friction, and it could cause the rubber to start to absorb water and swell. And that's when you might have issues, getting your sensors back into your bulkhead. And this also goes for the cable connectors as well, on your cable and on the top of your instrument. So to take care of them, take the sensors and port plugs out. Use a lint-free cloth or soft brush to clean off old grease and dirt. Then apply a little pea-size amount, again, of silicone grease. rub it on the black neoprene just enough to make it shiny, and you're going to get both the male and the female connectors on these. And you can use a flux brush, like I mentioned earlier, or another small brush to help you get between the pins. And then always clean and lubricate your sensors before reinstalling them in your instrument, or putting a plug back in. Then that's because wet meat connectors like to be moist and not dry. And just with that regular cleaning and lubrication, about once a quarter or so, it'll help prevent the swelling and maintain your connectors for a long, long time. And then a lot of deployable water quality instruments have wipers that help keep the sensor faces clean, especially if they're in the water for extended periods. For example, the Exosonde has a central wiper, and it's really powerful, but it definitely benefits from regular care. And it definitely should also be maintained before you put it into storage. So be sure to clean the wiper body and the brush head. You can rinse the brush in clean water and comb out any debris you might see in the bristles. And if algae or scum is really built up in there, you can soak it in white vinegar to help dissolve it, then rinse it off with clean water, squeeze out the excess on the brush, and then let it dry. And if you notice, like in those bottom photos there of the bristles, that if your bristles are starting to splay and lose their shape, you can soak the brush, disconnect it from the wiper, soak your brush in hot water. And then when you take it out, use a zip tie or a twist tie to tie the bristles to back together and reshape it, and then set it to dry. And that can help you get a longer life out of your brushes. And with any wiper, you'll want to replace the brush head as needed. And that's usually about annually, but it definitely depends how it's used. And then also inspect the wiper hardware, anything you can access like set screws and the motor shaft. Don't try to take the wiper apart yourself. You're going to want to send it annually or so for factory maintenance. That way they can take care of the motor and all the internal seals. And after you inspect everything on your wiper, you can run a wiper test, and that'll help check for stability and make sure that the brush is parking in the correct place and not over a sensor. Okay, here's the last thing to keep in mind before storing your instrument. You got to dry the outside of your instrument accessories and cables before you put them away in a case or cabinet. That will prevent mildew or mold from growing on it. And you really don't want to put any of your field equipment away wet, or else they'll really start to stink, and you'll notice the next time you go to use it. So you don't want that. So you can leave the case open if it's not completely dry, and that way you can make sure it can air out over time. And when I say dry your instruments, we're not talking about the sensor tips here. Instructions for each sensor are coming, so stay tuned.
Oh, hi everyone. I am excited to walk you through what you need to do for short-term storage. So let's get started. For field instruments, we're defining short-term storage as anything that is less than 4 weeks. So that could mean storing it for just a few minutes to overnight to up to a few weeks at a time. Here are some examples of when you might need to store your sensor for short term. So if you are traveling to and from the field site, whether you went for a sampling trip or bringing the equipment out for a site installation, or potentially removing it after decommissioning a site. When you travel between sampling sites for collecting spot or discrete samples. Or if you have a deployment site and you need to bring the instrument back to the office or lab to perform regular maintenance and calibrations, or just even swap out sensors or the sonde itself. So we're going to get into how to store for short term. First, I do want to note that all YSI environmental sensors can be stored this way, and these pointers are genuinely going to be true for other brands as well. All you're going to want to do is store the sensor in a moist air environment, otherwise known as water saturated air. And to do this, you're just going to put a small amount of tap water or a damp sponge in a calibration or storage cup, and then just tighten the cup onto the sensors. This can be tap water, bottled water, or even site water in a pinch. But if you do end up using site water, go ahead and change it out for tap water as soon as you can. And you don't want to use DI or distilled water for this. and you don't want to submerge the sensor in the water because it can shorten the lifespan. This is especially important for pH or ISEs like ammonium, chloride, and nitrate because it can deplete the reference solution and potentially cause them to drift. You're also going to want to make sure the calibration cup or storage bottle is completely to fully sealed on the sensors to prevent them from drying out at all. And then you can go ahead and store your instrument in a case for transportation or in a cabinet to protect it if you're not using it right away. If you're storing your sensors for closer to 4 weeks, so the longer side of the short-term storage, you should check on them periodically, just a couple times, just to make sure they're not drying out. If your calibration cup isn't fully sealed and the sensors do dry out, you still might be able to save them. If your DO sensor does dry out, you can go ahead and try to soak it in tap water overnight to rehydrate that membrane or the optical DO cap that's on it. This will usually work, but if not, you may still have to replace it. And then the same is going to go for your pH, ORP, or ISE sensors that dry out during short-term storage. You can try to rehydrate a pH sensor in pH 4 buffer and rehydrate the other ISEs in their standard solutions. Again, you may need to replace the sensor or the sensor tip if the data indicators are off or if the sensor isn't calibrating for you. If you have an instrument like the ProSwap or the Pro 30 that only measures conductivity, temperature, or an optical parameter like turbidity, rhodamine, chlorophyll, dissolved organic matter, or UV nitrate, you can go ahead and store it dry. Just cover the sensor tip to protect the glass or sapphire sensing window. You can use a shipping cap or a sensor guard to cover the tip. I always recommend keeping those little shipping caps for the sensors when you get them. They come in handy for stuff like this. And I do want to note that this does not apply to the optical DO. The optical DO needs to be stored wet, so keep that in mind. Some instruments measure vented level, like the ProSwap Logger. So this means that it has a cable that allows the instrument to compensate for atmospheric pressure by venting to the air. It also has a desiccant tube connected to the cable to keep water out. That's what that green arrow on the slide is pointing to. That's the desiccant tube. You're going to want to remember what color your desiccant beads are supposed to be so you know when to change them out. Usually any desiccant you buy from YSI will be blue when dry and pink when wet, but this can vary by manufacturer, so please double check what brand you have and what color they're supposed to be when dry and wet. And to store it, you'll just want to place a cap on the end of the desiccant cartridge to keep the tube sealed, and if you do end up detaching it from the cable, you'll also want to cap the end of the cable. So that's going to wrap up short-term storage, and here's just a summary of what we covered. Short-term storage is going to be any amount of time that's less than 4 weeks. It's safe to keep all of your sensors installed and stored in water-saturated air to keep them moist. You're going to want to seal your storage cup to keep your sensors from drying out, especially your pH, ORP, and other ISEs, as well as DO. And you can store your sensors that only measure conductivity temp or optical parameters dry, except for the optical DO. And like Katie said, go ahead and make sure you dry the outside of your equipment before putting it away. You don't want to develop any growth or funky smells when you go to bring out the equipment to use it again.
And now we're going to move on to long-term storage. So long-term is going to refer to any amount of time greater than 4 weeks between uses. And keep in mind the way you're going to store each sensor type varies. So take some notes during this section and also consult your manual if you need to double check anything. And if you store your sensors right, it's really going to make a big difference in the long run and the performance of your sensors. So here's some examples of when you might need to use long-term storage techniques. You might find yourself between projects due to funding cycles or waiting on grants. Your agency could be shifting priorities, meaning you won't be sampling for a while, or if your study just ended, or maybe you have a sampling off season. So this could be when you want to avoid having equipment out when the water freezes in winter, or maybe you want to avoid extreme weather like flooding or hurricanes like that we've been experiencing. And those could, potentially wash away your equipment. Or maybe you just want to avoid a season of non-target conditions, like maybe you're waiting for the rainy season so that you can collect samples during high flow. And then some of you might use your instruments for academic purposes to teach students, so you don't use them during academic breaks. And since summer vacation in the US is still 3 months long, this would mean you need to use long-term storage techniques. And here's my hot tip for you if you have an EXO. I always suggest removing all your sensors from your bulkhead before you store for a long period, even if you don't have to for their specific storage requirements, because it gives you an opportunity to check everything for damage, clean the ports, and perform maintenance on all the wet mate connectors and the O-rings. And remember that if you have an EXO, you love grease, so lubricate your connectors. And this is any silicone O-ring grease that you can get at a hardware store. And then cap the connectors as well, like Jessica mentioned, with a shipping cap. These come with your sensors. It's really nice to just hold on to these, and that will help prevent dust accumulation on the connectors after they've been greased. And I'm not going to leave you out. If you have a Pro Series or other instrument with milli-spec or LEMO connectors, so here's my tip for you. You don't need to remove your sensors, like we said earlier, because they don't need the same maintenance and relubrication like the wet mates do. Of course, you can take them out if you need to swap sensors or for maintenance or specific sensor storage, or if you suspect an issue, but otherwise go ahead and keep them installed to prevent wear and tear of the connector, and also keep extra dirt or dust from getting into the ports. And I already talked about things you need to do before storing, but we're really going to hit it home for you in this section because you don't want to neglect your equipment before you put it away for an extended period. So do some general maintenance first. You're going to disassemble and disconnect cables and sensors as appropriate for your instrument. Remove any tape or sleeves you may have put on them so you can get everything cleaned up really well. You can see in this picture, there's the EXO has a green tape on it, and that was to prevent growth on the sign, or to help easily remove growth on the sign, and then copper tape on the sensors for anti-fouling. And you can take all that off. Once you take it off, you can make sure everything's clean and really inspect everything for damage. And then take the time to repair and replace parts. That way everything is ready to go for next time. And since you're going to store your equipment for a long period, this might also be a good time to send your equipment in for factory maintenance, since you'll be having instrument downtime anyway. And with long-term storage, you might not be touching your instrument again for several months, and you don't want to leave batteries in your instruments because they can leak and corrode the internals, especially if you use alkaline batteries like our EXOs and some of our other sensors or instruments do. So always remove them from the instrument. If you notice the battery compartment is dirty, you can clean it by squirting some DI water in to rinse it. Wipe it out with a lint-free cloth, make sure it dries completely. If there is corrosion on the metal terminals, you can clean and polish them with baking soda is really helpful to help neutralize and remove battery acid from the terminals. Also, if your instrument has an internal battery compartment, it will likely have a pressure relief valve. That's for safety purposes in case the battery is off gas. So inspect the valve to see if it's popped up on the EXO 2 and 3. It's here in the battery cap. If it is, you might need to push it back in before you put it back in your instrument. And then next, clean off any dust and debris on the battery cap as well, including the threads and the O-rings if you have them. Again, the EXOs have O-rings around the battery caps, so you can clean and lubricate those. And then store your instrument in a cool, dry place if you don't have any sensors installed. And this is some repeat info on cleaning, but I want to make sure you're doing a deep clean before you store your instrument long term, because anything you leave on it is going to either grow or dry out and crust on after months of sitting around, and it'll be even harder to get off the next time you want to use it again. So again, these are tips for cleaning your instruments. We'll get into sensor specific cleaning in a little bit. So first off, warm soapy water will remove most of the dirt. You can just use simple green spray or a few drops of dish soap as well. You can see simple green spray is one of those spray bottles up there in the photo. And then if you need to do some scrubbing, you can use different brushes for different things. A kitchen brush or a bottle brush is really helpful to reach down into the sensor guard and really clean sediment down out of there. Even a grill brush, wire brush is helpful to clean off anything that's stuck on the outside of the sensor. Obviously, be very careful not to damage anything if you're using a wire brush. A toothbrush can help get around sensors as well as the connectors, but mind the sensor tips. We generally don't want to be scrubbing them. And then if you're having a really tough time, you could even resort to a paint scraper to remove mussels or barnacles, let's say. But be very careful if you're using anything sharp. White vinegar, again, is your friend, or bleach. I know somebody asked about bleach in the Q&A I saw. So they're also good tools for your belt for cleaning off your instruments. A 15-minute soak in a 1-to-1 dilution can really help get things clean, and you can leave it for up to a few hours. With bleach especially, you don't really want to be using full strength bleach, so definitely dilute that at least 1-to-1 before you use it to clean your instruments. And you don't want to be soaking all your sensor tips in bleach because some of them can have bad reactions. So if you're cleaning your instrument on the outside with bleach, just wipe it down on the top or wash it down on the top with bleach on the outside. You can also use germicidal spray cleaner for decon, like Quat, if your SOP calls for it. But be careful with that. Again, you want to avoid the sensor tips. Make sure you rinse your equipment off really well with water as well, especially between each cleaning method, so you're not mixing chemicals. And then if you're finding cleaning is a big chore and it's taking too long, especially if you have deployed equipment, make sure you're using anti-fouling accessories like copper tape, copper guards, heat shrink sleeves, and sea spray. That'll really help prevent fouling or help you quickly remove it. So in these photos here at the bottom, you can see this person is removing heat shrink sleeves from their son. So there's fouling on the outside, but once you rip off that sleeve, it gives you a nice, clean, brand new son to work with for next time. And then once everything is clean, you can go ahead and put fresh grease on your O-rings and any wet mate connectors on your instrument, like we talked about, cables and sensors. Again, just a little dab on your finger. Don't forget, wet mates like to stay wet mate. Yeah, I'm sorry for that. We just want to make sure you're still awake, so there's a little joke. But anyways, then do a final visual inspection of all the parts to check for damage. And if you have a deployment site, like a buoy or profiler, or a land-based site, part of your long-term storage means you'll need to decommission the site. So think about what you need to do with all your equipment. Go ahead and responsibly dispose of all the consumables like desiccant packs and old batteries. Make sure you follow the proper disposal techniques for everything, especially any batteries or electronics. And this also includes anything you might pour down the drain like calibration solutions. So always follow the guidelines from your local water authorities. And then clean and organize everything you might reuse. You can pretty much scrub the heck out of your deployment site equipment, like the SON deployment tubes, mounting hardware, any enclosures, and that way you can make sure to get everything really clean. In fact, if you have a buoy or a pontoon, if you pull that out of the water, then you can power wash it to get all the growth and deposits off of it. And if you need help cleaning it, you can also spray it down with simple green and then power wash it. And then before you redeploy it, you can paint it with a new coat of anti-fouling paint. Like you can see in that bottom photos, it got a brand new coat of paint on it, and that'll help keep it clean for the next deployment. And then when it comes to your solar panels though, make sure you're gentle with them so that you don't damage the solar cells. They tend to accumulate bird poop and debris because they're flat and exposed, but just use a soft cloth with water to get it off if you can. Don't even use soap, and definitely no abrasives. And the thing about that is if you spray them with sea spray, which is that anti-fouling spray, it will help keep them from accumulating dirt and also make them easier to clean. That way, when you just go to wipe it off, the stuff will just come right off. And then make sure you store all your electronics in a climate-controlled environment and not just out in your loading bay. We're talking about batteries, instruments and sensors, of course, data loggers, modems, communication devices, solar regulators, solar panels, and battery chargers. And then one special thing to pay attention to is if you have a buoy with a beacon, aka a light used for visibility when it's out on the water, some of those have an internal battery and solar panel. And they need to be left out and exposed to the sun during storage. That way they can properly power cycle. All right, now we're finally ready to get into the specifics of long-term sensor storage. So I'm going to let Jessica take it away.
Thanks, Katie. So since the methods vary by sensor type, we decided to break this down by sensor, and we're going to talk about how best to care for each one and then how to store them. So hopefully this section answers a lot of the questions that you might be thinking of already. Starting with pH and ORP sensor care, there's going to be 3 options of cleaning a pH sensor depending on how dirty it is and what kind of fouling you're seeing. So if you're just needing to clean off some light dirt and debris, you can soak the sensor in tap water with a drop of dish soap, swish it around, and then rinse it off really well with a clean tap water. So that's one way. And if you do notice your bulb is foggy, you can try a 30-minute soak in 1 molar hydrochloric acid or undiluted white vinegar. If you don't have HCl, then go ahead and rinse it really well and soak it for about an hour in tap water. This long soak in tap water is what we would call a cleansing soak, if you've heard of that term before. It's really important to soak in tap water afterwards to draw the chemicals out of the reference junction. You don't want to use DI water for this because it will deplete your pH reference solution. If you notice it's taking a long time for your sensor to stabilize when you calibrate, that would be a sign that your reference junction is fouled. Bleach can help draw this out, and it can also help if you have tough fouling on the bulb that won't come off. You can try to soak the sensor tip in a 1-to-1 dilution of bleach to water for 15 minutes and then rinse it off with tap water. To make sure you remove all of the bleach, you do want to soak it for about an hour in tap water. So do that cleansing soak afterwards. And also, if you try to soak in, or if you try to soak in HCl or vinegar and bleach, so if you try multiple methods, you do need to rinse between them, or else you could cause a very bad chemical reaction that we want to avoid. So make sure you're cleaning really well or rinsing really well between those soaks. If these cleaning steps don't work, you might have to replace the pH sensor or the module, but plan to do that after you take it back out of storage. Since the pH bulbs do have a usable life of about a year, whether they're being used or not, you can go ahead and wait to do that when you take it out of storage. So after you've done the proper care for your pH sensor, you can now go ahead and store it. If you have a single sensor instrument with just pH, you can leave the sensor installed or remove it. Either way, you're going to immerse it in a bottle with storage solution, which could either be 1 molar potassium chloride or pH 4 buffer. And we do recommend that you leave the sensor guard on to protect that bulb. If you have a multi-sensor instrument, you can remove the pH sensor and just make sure you plug the bulkhead port that you removed it from, and then immerse the sensor in storage solution. You can use the original storage bottle that it was shipped with if you had kept that, or just a beaker if you don't have that bottle anymore. Then store the sensor in a cool, dry place. If you have a lab or an office where you have a cabinet to put it in, that's great. And this is going to go for all of your sensors. They should be stored indoors in a climate-controlled area. If your sensor does have a removable tip, don't remove it before storage. It could potentially destroy the O-rings on the modules, and you won't be able to put the tip back on. You can replace it if you need to when you take it back out of storage, and keeping it on will also just help protect the sensor internals. To clean ammonium, nitrate, and chloride ISE, you can use a squirt bottle to spray them gently with DI water to remove the debris, and then soak the tip in its standard for at least 15 minutes. You're going to want to use the standard that's going to be closest to your expected sample measurement, so either the lower or higher concentration. For those of you who are measuring in natural water bodies, you're probably on the lower end of the sensor range. So you would just go ahead and use the lower concentration standard, which would be 10 milligrams per liter for the nitrate, for example. After the soak, go ahead and let it air dry because you don't want to wipe the tip. Those membranes are fragile and you don't want to scratch it or damage it. And only the chloride ISE can be gently wiped with a lint-free cloth. If you do see deposits, you can use a fine emery paper to gently buff off the surface, but that will only be for the chloride ISE. We want to protect the sensor membrane during storage, and one way to do this is by using the storage bottle that it came with. Generally, you want to remove the sensor to store it, but you can leave it installed if it's a single sensor instrument and just put the bottle over the tip. There are going to be several acceptable storage methods, so just use the one that's going to work best for you or that is potentially in your SOPs already. One option is to store the ISE dry with nothing in the bottle. If you do leave it dry, it's important to rehydrate that membrane before the next use by soaking it overnight in the standard that's closest to your expected measurements. The reason that we still will put a bottle on it even dry is just to protect that tip or that membrane. Another option is to keep the ISE in humid air. So you'll put a small amount of standard in the bottle and seal it. You don't want to use tap water or DI water for storage, and you don't want to submerge the sensor tip in the solution. Keep the sensor upright so it doesn't come in contact with the solution. As you can see in the photo there, the sensor tip is kind of just hovering above that solution, not submerged in it. That's great. That's kind of what you want to see. And again, use the standard closest to your measurement range. That way, if it does tip over and submerge the membrane, it's really not going to be a big deal and it's not going to damage it. Since the ISE usable life is generally about 3 to 6 months, you'll likely need to replace the sensor and the sensor tip before using it again. Next, we have electrochemical or membrane-covered DO. To care for the sensor, remove it from the bulkhead if you need to, and remove the used membrane cap, which is that red or the yellow cap there. Then rinse the electrode with DI water. If you're having any issues calibrating or notice unstable readings, your sensor might be tarnished, and you can use a fine grit sandpaper to gently buff that anode and cathode to remove the deposits. You're not going to want to do this too often. The electrode should be buffed at most twice a year. And then go ahead and dry it with a lint-free cloth and install a new dry cap without the electrode solution or without the electrolyte solution to protect the electrode. Then you'll just go ahead and store it dry. If you do end up filling the cap with the electrolyte solution and leave it for a long time, it could leak out over time and your sensor tip could be covered in little crystals. That's not a big deal, but you'll need to just clean it again when you take it back out. And if you have a multi-sensor instrument, the DO sensor can also be left installed as long as the other wet storage sensors have been removed. Optical DO is going to have a very different care and storage instructions from the membrane DO that we just went over. To clean off the debris, you're going to use a lint-free cloth and a soft brush and some mild soap to remove any buildup. If you need to remove tough fouling, you can soak the tip in a 1-to-1 vinegar solution for about 30 minutes. You're never going to want to use abrasives, alcohol, or any harsh chemicals on this sensor. Abrasives can end up scratching the black paint off that TO cap, which can let light in that will interfere with the measurement. If you notice that roughly 30% or more of the TO cap is scratched, you're going to want to go ahead and replace that. Always keep the optical DO cap wet. If it dries out, you can try to rehydrate it by putting it in tap water overnight. The DO cap generally has a life of about 1 to 2 years, but may last even longer with proper storage and care. So go ahead and make sure you're paying attention to your data and your calibrations. If you are having trouble calibrating, that may be a sign that you have to replace that cap. So just go ahead and replace the cap on it. We always keep optical DO wet, so we're going to store it in a water-saturated air environment. Remove the sensor if you can and store it with the shipping cap with a wet sponge. If you don't have that shipping cap, you can store it in a bottle with a small amount of water or a wet sponge, and just make sure to seal it to prevent evaporation. If you have a Pro Solo and use the optical BOD cable, you can store the sensor in the bottle with a small amount of clean water. That's going to work for both short and long-term storage on that one. And make sure you're checking on the sensor periodically just to make sure they're not drying out. You can always add just a little bit more water or wet the sponge again. And now I'll let Katie go over the last few sensors and wrap us up with a summary of long-term storage.
Thanks for covering those more finicky sensor storage details, Jess. The next few are pretty straightforward, so I can take it from here. So first off, conductivity, temperature. These sensors are pretty robust. So even if they have a layer of fouling on them, they can still give you good data. So, but to clean them, you can swish the sensor in water with a drop of dish soap. And then if you just need to remove buildup, you can soak it in 1-to-1 vinegar. But just never use bleach on CT sensors because it can tarnish the electrodes. So that's why we don't want to be, submerging all our sensors in bleach, because they have slightly different care for each one. So for standard CT sensors with nickel electrodes, like the ProDSS CT sensor that I have here, you can clean these electrode channels with a small pipe brush that comes with the sensor. Just insert the brush into each of the 2 channels, and then clean them gently with small strokes, and then rinse them well. And then if you have an exo wiped CT sensor, which has graphite electrodes, you can use a soft brush or a toothbrush to clean the prongs. And then after it's clean and dry, being key, when you test the sensor in air, it should read 0. So that's a good indicator that you've cleaned it well. So CT sensors are stored dry, but they can also be stored wet with no issues and without causing problems to the sensor. So if you remove all your sensors from your instrument, just store it dry. But if, for example, you have an instrument with only CT and pH, like the Pro 1030, you can go ahead and store both sensors in pH storage solution, and it will be absolutely fine for the CT sensor. Next, optical sensors are also easy to care for. So these are like turbidity, chlorophyll, DOM, dissolved organic matter, UV nitrate, and rhodamine. All you need to do is use a lint-free cloth to wipe the sensor faces clean. And for this, it's really important that it's a lint-free cloth like a Kim wipe, because any fibers from a paper towel can fluoresce, and that can interfere with your readings. So also be careful not to scratch the sensor windows, especially if they're made of glass. They can be more fragile. But some sensors like the EXO and Pro DSS optical sensors are made with sapphire windows, which are harder than glass, and they can be gently buffed to remove buildup and won't scratch easily. And then optical sensors can be stored dry, like the CT though, they can also be stored wet with no issues. So to prevent scratches, you'll just want to cover the sensor tip with a shipping cap like this one here, and also cover the connector end if you removed it from the instrument. And last, we have the depth sensor. So you might have one integrated into your instrument body or into the cable assembly, or this can also apply for a standalone pressure transducer as well. You just want to clean off any debris. If you have an internal depth sensor specifically, you want to look into the depth ports. If you see anything blocking them, flush them out with a syringe. We include one with every instrument that has an internal depth sensor. And then just keep flushing with a syringe and clean water until the water comes out clear. And if you're noticing that something's stuck in the holes, if you're looking in there and you can see something, you can soak it in vinegar. And to do that, you can just take your instrument, put a little bit of vinegar in your calibration or your storage cup, tighten it on the instrument, tighten it because you don't want to dump vinegar everywhere. And then you're going to invert the instrument so that vinegar enters the ports, let it sit for 15 minutes, and then flush the ports again with clean water. And if you do see something trapped in there, never insert anything in the holes to get it out. It can damage the pressure transducer and it would need to be repaired by the factory. Depth sensors can all be stored dry. And internal depth really needs to be stored dry because we want to prevent mildew growth in the ports. And that's it for care and storage of each sensor type. This was a lot, so let's go ahead and hit the high points again. So first, before you store your water quality sensors for long term, it's a good idea to disassemble as needed for your instrument, remove tape, sleeves, or zip ties, and always remove internal batteries so they don't corrode your instrument. Be sure to responsibly dispose of any consumables. And then clean your equipment to remove dirt and fouling, dry off the outside of your sonic cables and accessories, then inspect for broken or old parts and repair what you can. And don't skip lubricating O-rings and especially wet mate connectors even before storage. And if something needs to be sent in for factory maintenance, you can go ahead and do that now. For the sensors, store optical dissolved oxygen and pH or P sensors wet according to their instructions, and choose either wet or dry storage for your ISEs or ion selective electrodes. And then all other sensors can be stored dry. Use their storage caps to protect the sensor tips and the connectors if you have them, or install the sensor guard if they were left in your instrument. And if you remove sensors, put port plugs in the bulkhead of your instrument to protect the ports. And finally, store anything electronic in a climate-controlled environment. So before you go, we mentioned the importance of sending in your equipment to the factory periodically so that they can keep everything in top shape for you. So please reach out to YSI customer support to learn more about our maintenance programs. And when you're needing to restock or find replacement parts, remember that you can check ysi.com. There you can find calibration solutions, manage replacement modules, anti-fouling accessories, handheld instruments, sensors, and we've also added more to what you can buy on your own, including more EXO parts and sensors. So that just makes it even easier for you to get what you need yourself. So be sure to check it out. And finally, I know we covered a lot of detail today, so if you're feeling overwhelmed or not sure if you plan to do everything in-house, just know that you have the YSI services team in your corner if you need us. You can create a contract that works for you, whether you need help just with site design and installation or training your team. If you want a one-time vehicle survey for spatial data analysis, And then if you need routine maintenance and calibration on your sites, or even if you want total end-to-end data collection, meaning the services team will handle everything and just gives you a custom data report, you can go ahead and reach out to systems and services team if you are thinking about it. And that's all I have. So I hope you guys learned something helpful. And now I'll hand it back over to Nate to take us out.
Awesome. Thanks, Katie. So if you're looking for some extra tips about instrument care, YSI offers how-to videos in the form of both EXO University and ProDSS University. These are both video libraries with even more practical tips and step-by-step instructions, so you can watch and follow along. They're both free resources with videos detailing the setup, calibration, maintenance, and storage of EXO and ProDSS. And actually, a lot of these tips can apply to other instruments with similar sensor types, so be sure to check them out if you need some additional guidance. We've had a lot of great questions come in so far. I've been trying to peek in it here and there. I'm sure Katie and Jessica have also. As a reminder, if you still need to ask your question, you can drop it in the Q&A panel in the bottom of the webinar interface. So please let us know if you have any questions or topics you'd like more information on. And then I'll hand it over to Katie if you have a question you've seen that you'd like to start us off with.
Yeah, for sure. Let's see. So I've seen a lot of questions and comments about the pH and DO modules and knowing when to replace them. And we also talked a little bit about that in the webinar, but we didn't go into like really the details of the data indicators you should be looking for to determine when to switch them out. So let's start with how to know when to switch out your pH modules or the sensors. It depends what kind of instrument you have, but with EXO and ProDSS instruments, you would just be swapping out this top cap here, this module that has the reference solution and bulb in it. The sensor body is going to last you for a long time. And then there's other instruments that YSI has that where they're smaller sensors. I don't have any here on me, but you would swap out the whole sensor instead. So when to know to replace them. So first you can look at pH millivolts, including the delta slope and the millivolts per decade. So you'll see these values in your calibration report if you get one from your instrument. But if not, the delta slope is just calculated as the difference between the millivolt values as they were read in the pH 7 buffer and the 10 buffer while you're calibrating, or 7 and 4 if you calibrate with those instead. Either way, the range that you'd want to see in that delta slope would be between 165 and 180 millivolts. That's plus or minus 50, so you have a good range there. And if you're doing calibration with 7 to 10 buffer, it would be a negative delta slope, and it would be positive, conversely, if you use 7 to 4. And then also look at the millivolt per decade. So again, that's in your calibration report. It should be in the range of, I believe, 55 to 60 pH units per millivolt. If you don't have a calibration report that gives you that number right out for you, you can easily calculate it by just dividing the millivolt delta, the change in millivolt, by 3, which is the number of pH units you've changed between buffers, 7 to 10 or 4 to 7. So it's pretty easy to calculate yourself and then determine if it's in the right range. And then if you have a smart QC, like the instruments that can connect to core with the smart sensors on EXO and ProDSS, you can also look at whether it's telling you if it's a yellow or a red QC score. And that should give you a good indicator as well. But keep in mind, if you do set up in core a reminder, you can set up an automatic reminder where it will remind you to replace your module. Your QC score is going to be automatically read, even if it's calibrating well, if you've passed that due date. So keep that in mind. And I also want to mention the EXO calibration worksheet, as well as the Smart QC handbook, if we could pop those in the chat. Those are good guides to help you, you know, they have all the ranges in there that you need to look for, helps you with troubleshooting. And it will work even if you have, you know, a different instrument other than the EXO or ProDSS. They, a lot of those tips apply to any sensor of the same type. And we also mentioned this in EXO University videos, so you can check those out as well. And then if your data is not looking good for your pH sensor, go through those cleaning steps that we recommended, the different soaking methods, then try to calibrate it again, see if it improves before going ahead and changing the tip. And then for the DO cap, if you're trying to determine when to replace the membrane cap for DO, you're going to look at the DO gain. So that's in a range between 0.5 and 1.5. And this number is related to the calibration coefficient. It tells you how much the sensor coefficient has changed between the factory set coefficient and the user calibrated coefficient. So if it's out of that range, then you might need to replace the tip. You can clean the sensor, factory reset it, and then try to calibrate it again and see if that helps. You can soak the tip overnight if you suspect it's dried out. So soak it in just tap water overnight if it's a DO membrane or optical sensor. See if that helps rehydrate it, give you better data. And then you can also soak the pH tip if you're still seeing bad results and don't want to quite change the tip yet. Soak it in pH 4 buffer, and that might help get you better data before you decide to change it out. And I saw, Jess, I want to take all of this. So maybe you want to go over the stocking pH and DO caps.
Yeah, yep, that came up a few times as well in the questions. So for optical DO caps, they last about 2 years, maybe even longer if they're kept moist on a shelf. So those will last a little while. Membrane DO caps will keep for about 6 months if kept moist. And pH sensors, on the other hand, they might last a year, maybe longer, up to 14 months. So you don't necessarily want to keep that many in stock and have them sit for years on the shelf because they may lose their efficiency by the time you use them. Even more important is the optical DO and the pH module warranties. Those are about a year, or they are a year, and 6 months for the membrane DO. So it is going to be in your best interest to kind of purchase them as you need them or just before you need them. That way, if you install one and it potentially, if it has an out-of-box issue, you can get that replaced under warranty. So yeah, just keep that in mind.
Yeah, so we're talking about if you're buying a bunch of caps or tips in advance, you know, keep in mind that those shelf lives and also the warranty time period. So you're not buying, you know, like 10 backup tips and just keep them on a shelf for a long time. That might not be ideal. So there's a lot of questions here, so thank you guys for submitting them. There's a couple that I wanted to go through with you. So I believe we covered this, but Bryson mentioned, do you recommend using bleach for decon between sites? Yes, absolutely. But like I said, you know, you probably want to use a dilution of bleach, at least 1-to-1. So you're not using the really undiluted bleach on everything, a little more dangerous. So you can spray everything down with bleach. I wouldn't soak all of your sensors in bleach right off the bat because, like I said, CT doesn't like bleach. You want to follow the specific sensor care instructions. If you want to soak all your equipment in bleach, remove all of the sensors from your bulkhead, plug the ports, and then you can soak all of your, like, you know, your cables, your equipment, and everything in bleach if you need to. And then follow the specific care instructions we talked about for each of your sensors. Otherwise, you can wipe things down. I saw a question about wiping down with wipes, like Clorox wipes, I'm assuming. You can definitely do that. Again, be mindful of the sensor tips. You don't want to be wiping Clorox on those. And then, you know, after you wipe everything down with Clorox, it's a good idea to rinse it off with clean water, just so you don't have chemicals, you know, sitting on the plastic and the other materials on your equipment. And then I saw a question about using Krytox specifically, not generic silicone grease, to grease wetmate connectors for your EXO. We do give you Krytox specific brand grease currently. It is not important to use that brand specifically. You can use any silicone grease that you can find at a hardware store like I mentioned earlier. The most important thing is, doing that greasing regularly if you have wetmate connectors, and then if you don't have wetmate connectors, also on any O-rings on your equipment or on your sensors. Let's see, Jess, did you have any others you want to take a look at?
Yeah, there was a few questions about how often should someone send in their equipment for factory maintenance. Since a lot of our sensors are user calibrated and maintained, you can do a lot of the maintenance and repairs yourself. We do like to recommend sending them in at most annually to kind of get the instrument a few extended years of time, but I'm sorry, I got sidetracked. If you have a wiper, though, is what I really wanted to say. If you have a central wiper, those have a lot of kind of moving parts internally, so it's important to send them in every year if you can. That way the motor and the internal seals can be serviced, so it keeps working well for you. Sometimes we do offer a winter maintenance program that usually runs from December to April, so just keep an eye out for that. But if you are experiencing any issues with your sensors or sonde that you can't kind of repair yourself, that's a good time to send it in as well. So anytime you can send it in for factory maintenance. There's not necessarily a set time of the year.
Yeah, exactly. And like she said, the winter maintenance special in the US, I believe, keep a lookout for that. And then, you can always contact our service center if you need more information, need help sending things in, or have questions in general. And then I saw a question that we get this one a lot. What about the period of calibration of sensors? The frequency of calibrating your sensors. And this is one that we get pretty often, and there's not really one right answer. We usually start out by, asking a few questions. How often do you sample? Are you doing continuous monitoring? What do your SOPs say? So sometimes you might be required to calibrate your instruments before every site you visit. So, if you visit 3 sites a week, you might need to calibrate 3 times a week, or maybe just once per week. And that's definitely up to your agency or group that you work with. But from our perspective, we usually start with once per month. So especially if you have a deployment, you have your sensors out in the field and they stay out in the field, we recommend starting with, going back to check on them at least once per month, if not a couple weeks, to make sure that everything's working well. You're not getting build up on your sensors while they're deployed. They're getting good data, and then you're not experiencing drift. So a lot of our optical sensors have really stable sensor measurements over time, so they won't need super frequent calibration unless you're seeing, something in your data indicating otherwise. It really comes down to the pH and ORP and the ISC sensors. They tend to drift a little more readily. So calibrating those at least once a month is going to be good for them. But I've seen people calibrate once every 3 months and they still get good data. It's absolutely possible to push that out. Yeah, it just depends what you're fouling at your sites like, the cleaning and the specific conditions that you're experiencing. So if you ever need help with that, you can be sure to reach out to us and ask questions more specifically. And we also cover, again, Nate mentioned EXO University. We have some videos on this topic, as well as a order of calibration of our sensors, of the exosensor. So, and it can also apply to other instruments you might have, but it helps walk you through, if I have, CT, DO, pH, and turbidity, which one should I calibrate first, and how should I structure my SOP to give me the best data possible? So we do walk you through some of that in Exo University.
Yeah, thanks. Thanks for all the responses, and thank you everyone for all the questions. We've still got a lot coming in. I know one that I saw popping up a lot was a little clarification between storing sensors in a water-saturated environment or storing sensors in water. Can one of you cover that a little bit more detail?
Yeah, I'll hop in. Jess, feel free to pop in if I miss anything. So generally, you don't want to be ever storing your sensors submerged in water. So for short-term storage, we have humid air environment. And that's because if you're storing and this is particularly, like we said, for those more finicky sensors like pH, ORP, and ISEs, it can deplete the reference solution over time. So the sample water, the water it's sitting in, will pull basically the chemicals that are in the sensor out of it. And that's going to deplete the life of your sensor. So it basically means you have to replace your pH tip sooner than you'd need to. Keeping them moist is key, so that we don't want to dry out the bulb of the pH module or the ICs, etc., DO membrane. So we keep them moist by keeping a small amount of water in there or a saturated sponge. And that's a similar reason for why we don't store any of our sensors submerged in anything, unless it's storage solutions specifically for sensor storage, like the pH sensor, store it in pH 4 buffer or KCl, similar for sensors with reference solution. So that's why, and that also goes for DI water. You never want to use DI water for storage. That basically is like a sponge itself. It leaches that reference solution out. That's why even if you're just doing a humid air environment for storage, don't use DI water in case your sonde or your instrument does tip over and DI water comes in contact with your pH sensor. It will deplete your pH sensor and it'll either just make it unusable or shorten its life, and we don't want that.
Awesome.
I think you covered all the topics, Katie.
Thanks.
Another question I've seen pop up a lot while we're talking about storing sensors wet is when to use DI water or when to not use DI water.
Yeah, so I basically never use DI water to store your instruments.
Yeah,
the only
just for
time you can
cleaning.
use it. Oh, what were you gonna say, Jeff?
Oh, I was just saying mostly just for cleaning in
Yeah, for cleaning, right? Cleaning is good, especially between calibration solutions. Absolutely spray them off with DI water. That'll remove all of the any interfering ions or things like that. Really good for calibrating. Really good just we mentioned spraying off debris with a little bit of DI on your ISEs, but then soak them in the standard. That way you're not, depleting the reference solution. Yeah.
All right, awesome. I know there are still a lot to look through. Was there anything else that was popping out to either one of you that you want to make sure we answer live?
There was a question about if you're removing the sensors, should you always cover the bulkhead or plug the bulkhead? I would say yes, just to prevent anything from getting into those ports, dust, debris, any liquids getting in there that you don't want in there. So yeah, if you have port covers, I would go ahead and plug those up anytime you don't have a sensor in the port.
Yeah, and our instruments ship with a few port plugs that you can use. And if you need more, you can also purchase more. And I also want to mention the cable connectors as well. So on the top, if you have an instrument with cables that disconnect, It's a good idea to keep the cable connector plugs installed as well. That way, the pins aren't getting exposed to the elements when you're using your instrument on the field, and, likewise not getting any debris or dust settling in there. Over time, that could interrupt the connection. I see a good one I want to touch on really quick. Jennifer asks to describe what I mean by trouble, if you have trouble calibrating. What I'm talking about here is if you're calibrating your instruments, and we're talking about in reference to how to know when to replace things, how to know when to send in for factory maintenance, things like that. If you are having trouble calibrating, what I mean is you might have data that's not stabilizing. So you're watching the live, graph of your data, and it's not quite, becoming stable on a certain value. If you have a smart sensor that does smart QC, it won't say stable. So it kind of tells you if it's stable or not. And then by the end of your calibration, you look at those data indicators we talked about for specific sensors. There are more indicators you can look into in the Smart QC handbook to tell you if you had a good calibration. So check that out if you need help determining if your calibration was good. But then if you have a smart sensor at the end of your calibration, it will be yellow or red if it was not a good calibration, meaning the data was, for whatever reason, depending on the sensor, the data was not within the expected limits. So from the factory, our sensors have expected limits that they will calibrate within. And if it's outside of those limits, then the software will automatically flag it if you have a sensor that uses Smart QC. And like I said, if you don't have sensors with Smart QC, that's okay. Take a look at the Smart QC handbook, and your manual will give you the data indicators that you need to look for to make sure your calibrations are within the expected ranges.
All right, that brings us to the end of our scheduled time here today. If we didn't get to your question, we will make sure to follow up with you soon. I want to thank everyone so much who was able to join us for this presentation. Thank you to Katie and Jessica for all the information you shared with us here, and thanks to Kyle for helping us run things on the back end. From everyone here at YSI, we appreciate what you do to protect our water around the world. Thank you and have a great day.